If you already know ladder logic, structured text is the next language worth learning. Structured text is one of the 5 IEC 61131-3 programming languages. It looks like code rather than rungs, and it is the language employers increasingly ask for on top of ladder. This tutorial is for someone who is comfortable with contacts and coils. I will cover variables, the assignment operator, if and case, how to call a timer, and where structured text beats ladder. Every example is written and run in a free browser simulator. No vendor software needed. Let's go. Start with variables. In ladder, you work with addresses and tags. In structured text, you declare named variables with a type, then use the name everywhere. 4 types cover almost everything. Bool is true or false, the same as a single bit or a coil. Int is a whole number, a count, a set point, a state number. Real is a number with a decimal point, a temperature, a flow rate, a scaled analog value. And time is a duration. 5 seconds is written T#5s. So you might declare motor as a bool, count as an int, and temperature as a real. The name carries the meaning. That readability is half of why structured text exists. The single most important symbol in structured text is the assignment operator. It is a colon followed by an equals sign. Colon equals. It means take the value on the right and write it into the variable on the left. So motor colon equals true energizes the motor. Count colon equals count plus 1 increments a counter by 1. Output colon equals input scales nothing and just copies the value across. Watch the difference. A single equal sign on its own is a comparison. Is this equal to that? Colon equals is the action. Make this become that. Mixing those two up is the most common beginner mistake. Assignment is colon equals. Comparison is equals. Now decisions. The if statement is the workhorse. You write if, then a condition, then the actions, then end_if. For example, if start and not stop, then motor colon equals true. End if. That is a CON interlock in plain language. You can add else for the other path. If temperature is greater than 80.0, then fan colon equals true. Else fan colon equals false. End if. And you can chain conditions with else if for several bands. Notice how close this reads to how you would describe the logic out loud. If start is pressed and stop is not, run the motor. The same logic in ladder is 2 contacts and a coil. In structured text, it is 1 readable sentence. For anything with steps or states, use case. Case is the structured text tool for a state machine. You give it an integer variable, and each value of that variable is 1 state. The pattern is case state of 0, the idle logic and the condition to move to state 1. 1, the running logic and the condition to move to state 2, and so on. Case. A worked example. Case state of 0. If start then state equals 1. End if 1. Motor equals true. If done then state equals 2. End if 2. Motor equals false. End case. That is a 3-step sequence. Idle, run, finished. In a block you can read top to bottom. The same sequence in ladder is a wall of latching coils that is hard to follow. This is where structured text starts to pull ahead. Timers are the part ladder programmers ask about most. In structured text, a timer is a function block instance that you call. You declare a timer, say delay timer of type TON, the on-delay timer. Then you call it with named inputs. Delay timer, open bracket, in colon equals sensor, comma, pt colon equals t#3s, close bracket. In is the input that starts it. PT is the preset time, here 3 seconds. Then on the next line you read its output. Output colon equals delay timer dot q. Q is true once the timer has run for the full preset. So the timer counts while in is true, and Q turns on after 3 seconds. Same TON behavior you know from ladder. Different shape. You call the block, you read.q. That is the whole pattern. So when should you reach for structured text instead of ladder? 3 clear wins. First, maths. Scaling an analog input or computing an average is 1 clean line of structured text instead of chain of move and compute blocks. Second, loops. Processing 16 channels is a single for loop instead of 16 copied rungs. Third, complex state machines. A case block with 10 states stays readable where 10 latching coils do not. And where does ladder still win? Simple discrete interlocks and relay replacement logic that an electrician needs to read on a panel at 2 in the morning. Ladder maps to that intuition directly. The honest answer is that experienced programmers use both in the same project, picking the right language per routine. Reading about syntax only gets you so far. Fluency comes from writing it. Go to plcsimulationsoftware.com/plc-structured-text. There you can type real structured text in your browser and run it against test cases. The auto-grader gives you pass or fail on each one immediately. No PLC hardware. No install. No license. Write an if, build a case state machine, call a TON timer, and watch the values update live. That is the fastest way to go from ladder only to fluent in both. Subscribe. New video every Tuesday. See you in the next one.